All right, hello, good evening, happy Friday. For anybody that celebrates Thanksgiving, happy Thanksgiving yesterday. Let's see, we got live button here. This one looks like it's showing good. All right. Some coffee this evening. All right, so let's see. We've got sound definitely to OBS, so let's get that hidden away somewhere. Let's get our chats somewhere that I can see. How's it going, Beautograph? Good afternoon / evening / whatever time of day it is for you. I'm bad about. Still need to come up with a good greeting that is time of day independent, but it's nice to see you this Friday evening for me at least. Let's do this one. How's it going, Michael Pocuso? Good evening to you as well. Thank you to DJ Devon for dropping the link there. Howdy? Maybe I'll try to go with howdy. Let's see. I do kind of like howdy. All right, let's see. So for anybody that's new or catching this for the first time or on video or anything like that, if you haven't seen this program before, first of all, welcome. Thanks for tuning in. This is the Deep Dive, which is a weekly live stream program where we are diving into the internals of CircuitPython. That was the way that this show was started, at least. It was started by Scott Shawcroft, the lead developer of CircuitPython. As the lead developer, he typically works at a bit of a lower level than I do. So we do venture into the core from time to time when I'm on the stream, but we also spend time in library land and other places around the infrastructure and different bits and parts of the project overall. But let's take one step back for anybody that might be new tuning in for the first time. If you don't know what we're talking about, CircuitPython, this is the main website for it, circuitpython.org. This is a version of Python that runs on tiny computers called microcontrollers. There's a bunch of pictures of them here. There's also a live picture of one right here that's upside down. Put over maybe so you can at least have a chance to read it if you want. Microcontrollers that run CircuitPython, typically they'll connect to your computer. This one has a USB cable, so we're going to plug it in with the USB cable. It's going to show up like a thumb drive, and we're going to be able to edit a Python code file that's on that thumb drive. And when we save that code file, the computer, which on this device is inside of this little metal kind of protector case here, but the main computer is inside here, and it will actually interpret and execute that Python code for us. Right on side of that chip, and it can run independently of your PC, although using your PC is obviously a super convenient way to edit the code that's on there. So that is kind of what CircuitPython is all about. Today's device for me is this Qualia ESP32S3 RGB 666 40p TFT. This is going to allow us, I believe, to hook up this really interesting circular screen, which is what we've got here. So we'll be plugging that in here in a little bit, but let me take another step back and just finish telling you about CircuitPython. So if you want to learn more, circuitpython.org, that's a great place to go. Also encourage anybody that wants to learn more to join us on the Discord, which is linked down on the bottom of the screen, adafru.it/discord. During the live streams, typically folks are in the live broadcast chat channel, which is the chat that you see right below me on the screen. But there's also a couple of CircuitPython related channels if you want to hang out in there, get help with CircuitPython, or participate in CircuitPython development, or just hang out, say hi, enjoy the wonderful community. You can do all of those things on the Discord. CircuitPython is an open source project. Anybody's allowed to use it on their own hardware. Anybody's allowed to even port, a CircuitPython port to their own hardware. So there are plenty of third-party, companies and entities that create CircuitPython devices. Those entities, they don't have to pay anything to do so. It's fully open source project, so they're allowed to just do that whenever they want. The company that does, keep the lights on, so to speak, the company that is funding that open source CircuitPython project is Adafruit. This is their website, adafruit.com. They are a hardware and software company based out of New York. Most of the folks watching this are probably pretty familiar with them, but you can head over to adafruit.com if you want to purchase hardware from them. And by spending your money with Adafruit, you're of course helping them to be able to keep funding the CircuitPython project. So you can get yourself microcontrollers along with all sorts of bits and bobs to plug into your microcontrollers to interact with. And the special today for Festive Friday sale, 15% off this whole weekend, in fact. So if you want to get yourself some goodies, now is a good time to do it. Get 15% off if you can use the code FFS15 at checkout. So get yourself some goodies, and thank you for doing so. Thank you, of course, to Adafruit as well for supporting CircuitPython by paying the folks who work on it. There's a team of folks like Scott I mentioned earlier and a few others who work on the project full-time, and there are some folks like me who work on the project part-time doing various different aspects of it. So thanks to Adafruit, and thanks to everyone who purchases hardware from them. Okay, so today's device, like I said earlier, Qualia ESP32S2, no, S3 actually, TTL RGB. So this is my first time using this device. This is my first time using one of these displays. In fact, I was paid a visit by the Adafruit Fairy earlier today, and these devices just came. So this is first time powering them up. The only thing that I've done so far is take them out of the packaging. So we're going to need to get it hooked up, and then we're going to need to figure out what libraries and stuff we need to get it running and do that. And then once we get that running, I have in mind a new submission that I saw go by the other day in the Adafruit Shapes library that will be perfect for this type of display. And that'll make sense when we get to it. But first, let's get the display itself up and running. Howdy, C. Grover. Nice to see you today, my friend. First thing first is it's going to be plug it in. One thing we might do is go find that round. Yeah, did I get touch? Does this have cap touch? That's pretty interesting. Yeah, I guess I did get cap touch. Okay, so let's go the guide. Is there a guide? Display sheet Qualia. There we go. And again, so this is my first time with this hardware, so we need to get the ribbon cable plugged in, and then we can power it up. And it looks like our orientation is kind of vertical ways like this, so I will try to maybe do something kind of like that. One thing is I will need to we'll see if I can get this plugged in without pulling it a bit closer. I may have to get it out of the camera in order to get it plugged in, but I'll give it a try here. Let's get this here. And so I believe these are pretty standard ribbon cables. Let me get this one just wiped off just there. Bit of fuzz on there, okay. It's always good for your ribbon cables. Make sure they're nice and clean, free of debris. Debris? I think that's debris. I don't know why I went with debris there. Free of dust and dirt and hairs and all kinds of stuff. So, nope, we are totally out of the... Our little flap down here. I think that's in. Okay. Flap down. I will turn this. We can't quite fit everything, but honestly, all the action is going to be on the display. There's not much to see on the microcontroller. We'll plug this in. I don't have any idea if it's got it's probably got some code preloaded, but it may or may not be code that actually interacts with this display, and it looks like it is, so that's pretty cool. Oh, okay. Yep, let's do that one right there. Very good, thank you. Okay, so yeah, that powered up right away. There's some preloaded demo code right on there. It is probably Arduino, so if we check, yeah, there's no CircuitPy drive. We're going to have to get CircuitPython loaded on it, but this tells us, you know, our microcontroller is good. This tells us our display is good. This tells us our connection is good. A lot of good stuff going on with that. Pritam Das, hello to you, my friend. Thanks for tuning into the stream. Do you know how does the circular screen behave in terms of the dimensions? Like, how does it define a resolution? Is it like a rectangular screen, but with some pixels simply not present, so x 0, 0 is outside? That is my understanding, yes. My understanding is, for this display that I've got, it's 480 by 480, so it's a square. And my understanding is there are simply just pixels in the corners that are not visible. You know, of that 480 by 480, what you actually get, this is a total guess on my part, so we'll discover if I'm correct or not together. Don't take this as fact. My guess is that you get a 480 diameter circle, and then whatever pixels are on the outside of that are just gone, are you know, not visible. You could draw to them, you could set them, you can send them to the display, but my assumption is they just won't get seen. I would presume there's something in this about it. Timings, display. Oh, that's a lot of magic bits there, TF2 pins. This is not CircuitPython, is it? It is. Well, it's MicroPython in a way. What is this? This is not CircuitPython, though. What is this? Is like C or Arduino. What is this? Static. Yeah, it's totally Arduino. Oh, it says MicroPython, though. Is this like a core driver? Shared bindings? Okay, I don't know. I don't know if we need this. I don't know what this part is. If a board is tied to a specific display, then the board definition can initialize the dot clock display. Oh, okay. These are examples of initializing the display if you want it to be on board.display, I think. Okay, yeah, I think that's what's going on here. And then this is Python code. This is not C. So that stuff up there would need to be in the core. This stuff down here is more CircuitPython layer stuff. And I think there's a library for this now. So like ideally, we're not going to be diving into the nitty gritty of all of these different exact things here. Speed. These use I2C dot clocks. I guess this is like all kinds of displays. Well, yeah. 480 is actually, I don't know if it matters. That's the page we were on. Oh. Okay, there's a square one too. I mean, my guess is that the circle one probably thinks it's the square one. Like, it probably doesn't actually know that it's a circle. That's my assumption. Round. Oh, there it is. Oh, that might have been the one I was on. Yeah, it doesn't actually say on this page. Oh, interesting. I don't know. There's a spec sheet displaying it. No, yeah. There's a spec sheet that probably goes into more details. I'm gonna skip on for now. But yeah, my guess is it's a square and just doesn't let you do the corners. Let me catch up on the chat here as well. Tithe says that's my understanding as well. And Heil, how's it going, Tithe? Nice to see you, my friend. Mine came with no code, had a flash. with Python ESP tool, not a big deal, but could it be tough for a beginner? Yeah, not a big deal, but could be a big deal for a beginner. Could be harder for a beginner. Yeah, it's true. ESP tool is a bit of a tough one. I will say a good alternative to ESP tool is the web-based one, which I find even easier to use in Chrome. I think it's Chrome specific. I found that one to work pretty well. I think Maker Melissa worked on that. Shout out to Maker Melissa. It's a 720 square. Have to adjust the circle. It comes with the Qualia guide. Okay, I'll have to check out the Qualia guide. Here's a question for you. If I display a bitmap partially obscuring a QR code, would it be expected to render more slowly over the area that obscures the QR code, doing to have to work out alpha or pixel? I'm not positive that I understand your question all the way. Here I'll tell you what I think. I'll try to tell you. I'll have to show you because I can't really explain it very well. I'm not necessarily one with words, but let me show you what I am imagining you mean, and then you can tell me if that's correct or not. So you have a QR code. I'm going to use this blue square. We're going to pretend it's a QR code. You have a thing on top of it, whatever that may be, a logo or something on top of it. I'm going to use this smiley face, which we'll try to turn yellow briefly. Quickly, I mean. Line, color fill. You have a thing on top of it, so you have now a QR code and a thing on top. And are you asking, does it effectively work twice in order to fill in this section that is obscured now by the thing on top? Or are you saying, like, does it draw the QR code and then go ahead and draw this on top, thus, you know, wasting its effort by drawing the QR code behind? Qualia library I've been using for the 320 by 820. Yeah, I saw that really skinny display. I almost got that one. I ended up switching over to the Oh wow, there is a deer in the backyard right there. Okay. He's like, yeah. Anyway, how's it going, Dexter? Nice to see you. Let's see, Qualia library. Yeah, that skinny one is really cool. Make it square. Adafruit Tights guide shows the Qualia library. Nice. Let me copy that. Text. Yes, but face only half covers. Okay, so if this was over here instead. I don't know for sure. My instinct is that yes, it's gonna do double the work or whatever. Like, my instinct is that it is gonna spend time and effort rendering these pixels back here, and then it is also gonna spend time and effort rendering the ones on top of it. But ultimately, it kind of boils down a little bit to how you do it. If you just do it kind of the easiest way to code with the QR code library and then, you know, splash a bitmap, an on-disk bitmap or something on top without anything more fancy going on, then I do think it will spend time drawing both. If you use one bitmap and play some tricks in the code to where you can render only the parts of the QR code you need, I do think that's possible. And so you could avoid some duplicated effort, but you would also have to spend time working out the parts that you need. So it may or may not be net positive. I don't know. Hidden true, then false. Yeah. I think that it will by default spend extra time. Like, I think that it spends time to create the QR code behind, even though you can't see it in the end of the day. Now, what it may not do, like, I don't think it would spend time, like, sending the QR code via the SPI bus or whatever bus is in use. DisplayIO, I'm pretty sure, only sends the parts that are visible, the parts that are in front or on top, so to speak. But the QR code library would still spend time rendering that part of the QR code bitmap, I believe. Okay, so we need to get Did I grab this copy still? Yes. Ah, I got a 404 on this one. Oh, I copied too much. Here we go. Qualia. Okay, we need to check out this library as well too, I don't think. Okay, so you get graphics, displays, peripherals. You go Qualia, and then it looks like probably each one of those displays has a constant. We do that, tell it our rotation, and after that, we pretty much just have a display, like a normal old DisplayIO display that we could then set root group and do our stuff on. So we should be pretty good there. What do we want to grab here? I guess let's go, I know O. Looked that way. I'd hoped if the top one was not using transparency and palette and the QR was fully obscured, then no impact, but wishful thinking. Yeah, I mean, I think you could, I do think you could play some tricks in the QR code, the code that renders the QR code. It could be made to be a little bit more efficient, I presume. But yeah, like I said before, I also don't know if it would be net positive since you'd spend time calculating which ones need to be drawn. Bot Zerker over in YouTube says, hello, appreciate Adafruit's existence. Nice. That's awesome. Yeah, thanks for dropping by and mentioning that. I would totally agree. I know I am here streaming on the Adafruit stream, and it probably appears as though I speak on behalf of them, and I do to say thank you. But also as a user and a member of the community, I definitely appreciate and am thankful for their existence in the community as well. Okay, we need to get the reset button, which is where? So I see a boot button. And, oh, okay, here we go. This must be up, down, reset. Oh, that's interesting. I thought reset. I think on the Matrix portal is reset closest to the USB port, but now it's swapped to Forest potentially. The one thing is it does have a boot button. I don't know if it has UF2 bootloader already, so what we're going to do is try a double-click reset. That does not look like it worked. Let's try a slightly different timing. I don't see a NeoPixel. Yeah, I don't see a NeoPixel, and that didn't get us there either. So now what we're going to try is hold the boot button down and then press reset. So hold boot button, press reset, and then see what we have, which is, yeah, we might actually be in the same place as DJ Devon mentioned before, which is we need to use ESP tool or the web ESP tool like I was talking about. We need to load it. Basically, it's looking like we don't have UF2 bootloader yet. Well, I say yet. I don't even know if it's possible. And again, this is my first time using this device, so. Where is, does it say anything about the bootloader anywhere? Maybe on this CircuitPython or on what is inside there, CircuitPy drive. Okay, follow this. It says Qualia does not have, okay, that's good to know. There's no NeoPixel, so I wasn't just missing it or anything. So it does say double click. Plug it in using a known good cable. Double click reset. Double tap reset. Half a second, tap again. Some boards may not have UF2. Double clicking does not work. Follow install bootloader in this guide. Install bootloader. Install bootloader. Qualia ships with if your board has, you do not need to try to enter before. Okay, let's try a couple more times. I am in like a ROM bootloader mode now because I held this, but let's try double tap a few more times. Let me catch up on the chat also. I believe the final output of the display is updated to display after all the operations have finished that frame. No. Well, yes and no. I think yes in theory, but also if you have auto refresh on, then when that happens could be not necessarily under your direct control. But if you have manual refresh, then it's totally up to you. And then yes, it sends when you call refresh. Possible with that many pixels, a little slower. I mean, the display is huge for a microcontroller. I think there has to be an additional data lookup to store an alpha value, masking raw render, typical low memory. No NeoPixel and no UFTotal on most. Okay, no bootloader on most. Use web. Okay. First batch didn't have tiny USB. Wasn't even the library yet. Big hug to Melissa. Yeah. For sure. The library is going to make it a lot easier for sure. Okay, so we will let me try maybe one or two more times just to make sure. I kind of am thinking it's probably not there, but there's that. So this gives it half a second, it said. One more. It was a little slower. I think still nothing, right? Yeah, okay. This is a second bootloader ROM. Thanks to the ROM, you don't have to worry about damaging. Never be disabled and erase your factory. I don't actually need a factory reset though. How do we? This doesn't tell us how to do the bootloader. Reset and bootloader repair. Is this the next page? Okay, so just the title here is only half of it. Okay. Oh, I don't think that's gonna work. Okay. Chrome browser. I guess I did set up ESP tool the other day for doing something else. Get it in instead of UF2. Go to factory. Go for factory reset, yeah. I was looking at the title only. I didn't realize bootloader was on factory reset page. Download bin. S3. It's weird that but it calls it factory reset. Factory reset and bootloader. Okay. Plugged in, data sync, press and hold. So we need to go to ROM bootloader mode. You saw me do it a minute ago. I'm just going to do it again real fast without switching the camera. We should be in ROM bootloader mode now. It doesn't really tell us anything visual, but we can do this. So we're going to grab this link. We're going to go to here, drop that, go to this, connect. That is going to be this one, connect. It's going to do its stuff. We're going to then do what? We are going to choose our file. Where did this? I have so many things here. What is all this? Where's the browser we were in? Not there. Here it is. Display does freak out during an auto restart. Normally use manual refresh, never mind. Open instead of UF2. Okay, let's press connect. Some systems, Mac, JavaScript, code. Yes. Erase. This will erase everything. Once you have successfully connected, the toolbar will appear. Erase. I want to say I need to keep this like in focus. So what I'm actually going to do is scoot it over here. Oh, it's done already, actually. I think that I don't know if it can work in the background. I feel like I used this web USB serial thing once. I mean, I've used it a bunch of times, but one of the times I used it in the past, I thought I was minimizing the browser and it was actually not going while it was in the background, but that could have changed in the interim. That could be just me imagining it also. You'll see erasing flash. Do not disconnect. Immediately continue to programming. Choose a file. Click on the first choose a file. Find the bin that we downloaded. Probably we just press program, but it's good habit to actually read the instructions. Verify offset box next to file instruction is 0. 0, yes. Once you choose a file, the button next to that will change to match your file name. You can then select program to begin flashing. A progress bar will appear. 0. That changed. We press program. Progress bar appears. It's actually going pretty quick. I feel like in the past this was a little slower. Maybe it's different for different devices. Connect, erase, pick bin, program, reset board. I do it on the edge of frequently enough to actually memorize it. I would say, like, I probably could do it from memory, but I also know that if I mess it up, then I'll have to spend more time trying to fix it. So I'm a little deliberate and extra slow. It does look like it succeeded around the new firmware reset your device. So I'm going to reset once. I'm not exactly sure if that's going to take us right to the bootloader or if that's going to take us still to the demo. So all I did is press reset once. It did take us back to the demo with the rainbow action there. We do not have any CircuitPy still, which obviously we wouldn't. We don't have CircuitPy, but maybe double tap now. There we are, TFTS3 boot. Okay, did we ever download a UF2? I think I did. Need to clean up my downloads folder. Yeah, right there is a UF2, so let's drop that. Good idea to follow the instructions. In the future, you can just link people to this video, yeah. It depends on the day. Some days I'm in a very like adventurous, just blow through it from memory and see if I do it correctly. And other days I'm in a deliberately slow, stop and read the instructions. Today I'm more on the instructions slow, but I have never actually bricked a board, but I have temporarily bricked several boards by just blasting through stuff too fast. But yet I still do it sometimes. I'm not gonna lie and say I don't, but all right, let's see here. We should be on CircuitPy now, right? Yeah, CircuitPy. What do we have? Probably in our CodePy is just like empty or hello world or something. Let's get this minimized. Here we are. CodePy, just hello world. Okay, yeah. So then let's get this connected to TO action. Let's see. It's probably not on TTY ACM0. Let's go, let's check. What do we have? ACM1 must be on ACM1. I could connect on ACM1. I'm going to press reset, though, and see if it comes back as 0, because honestly, it'd be nice if it was on 0. Oops. Oops. Oh, my word. I don't know even what this will do. I didn't know you could put a star here. We should quit that before anything goes wrong. Okay, I totally meant to do an LS on that one. Let's go LS. I don't know what that's so weird. I don't know, a wildcard with TO. Would that open multiple connections? I don't know what that would do. It is still on ACM1. I'm going to try one thing, which is basically unplug it and then replug it. And if it comes up as 1 still, then we'll just use 1. Suspect it'll be back to 0 tomorrow after I reboot, but yeah, it is still 1. Okay. I like to try to keep it on 0, that way I can always just give it the old up enter here to start it up in my IDE, but I will spend the next couple of seconds next time. I'll spend the extra couple of seconds next time to get it switched over. Okay, let's get this reload. ARM is unhappy with me rebooting so many times. Okay, I wonder, is Qualia frozen in? It would make sense for Qualia to be frozen in. Qualia? High res? Qualia Circuit Python. Cool that the new release comes with blank. Yeah, I do like the template. I do like that this is in here. It's not a template exactly, although honestly I'd think it would be cool if this included some kind of like sample fields or whatever. TO open all the things, not yet. Let me see, not yet what? TO open all the things. The board is listed as TFT experimenter, but on the latest tinyUF2 it's updated to Qualia. I'm not sure what you said not yet to. I said something a little bit ago that I must have forgotten the context for. Sorry, Qualia. Let's see if the import of this works. This will tell us if it's frozen in. Nope. Okay, so let's go circup install that one. Circup install. Let's see if my version of circup is broken. I've been doing some work on circup. That reminds me, I need to merge that branch. Circup, I think, is ready for another look. I did some work the other day off of the stream, but I never did actually merge it back to the PR branch. Wow, that installed a lot of stuff. I guess this is like oh, okay, yeah. I was gonna say, I guess this is like one of the portal-based ones, huh? Okay. Let's go back to here. So we should be able to import this now. So, yeah, okay. Let's get our, let's take the simple test. We might as well just grab that straight up. Start with, right? This, what is that? So it's gonna, I mean, we don't really need a Wi-Fi just yet. Yeah, I don't know. We don't really need the Wi-Fi. I don't really need to see this. How do we? So it's just printing. Okay. Do you need to release the displays? Adafruit doesn't actually have it. Do you need release display? Usually you need like DisplayIO.release displays. I don't know. We do need a different one of these. Let's see if this lists. It does not. That'd be too easy. Let's see. Can't click through. Okay, let's get back to here. It's going to be the 480 by 481. Well, round 40? No, for what? 2.1 inch. Okay, 2.1 inch 480 by 480. This is the one. Okay, round 21. This is from displays.round. Oh. Do we need the small one or the big one? Square 34. I don't know. Let's try this. Would we need this? I feel like we would need this too. Displays has no round 21. Well, okay, this is a class though, not like a constant. Displays, graphics displays. Okay, we're in the wrong spot. Here we go. Graphics displays. What? Where's the constants? Unsure if there's an RTD yet. Good question. No idea. Not yet. Oh, frozen. Right. Thank you. That's what the not yet was too, is that it's not frozen in. Oh, now there's 2 deer out there. Okay, let's clone this. I'm tired of looking in GitHub. And then we open that. Do any of them use round 21? Are there any usages if we go back to where we were? Usages, no usages. Okay, so nothing actually does do this one. Okay, so we need to find those constants. Why is there not on there? I don't know where they would be. Displays. Load displays. Display folder files split. Oh, this is like dynamic. Okay, let's print it. We could print it, right? When in doubt, print it out, right? We need the Python one though. We have MPY. Let's delete that. Toddbot's QDI. Yeah, I want to use the library. This one's got all the sequence for initialization and all that. I want to try to use the library if we can. Thank you though for linking me there. Copy this. Divide. I wish I could change the order of these with drag and drop, but it does not work like that. I mean, you'd think it would be this. Or like, would be apparent from something in here. Oh, is it this? No, but that's the touch. Okay, let's just print it out. Here. Displays. Valid displays. So we should be able to print that. Displays.valid displays. So displays print displays.valid. Lowercase. I should have just tried, honestly. We could have, we would have gotten there. Gotten there if I would have just tried it. That's weird that the code where was that from? The example has it as shouty. Doesn't it? Yeah, that's weird. This is shouty. Does this work? I don't know if this works. I would be kind of surprised based on how this is now. Of course, we haven't seen if this works either. Oh, no, actually, this didn't work. Has no round 22, so that doesn't work either. I don't know how to use this. Maybe all shouty. Let's try that. Yeah. Yeah, they do need to be all shouty, it seems like. This is weird the way it's built up. I wish there was maybe there is somewhere and I'm just not aware of where it's at. I wish there was a listing though that said here's all the valid ones, right? Because this is just kind of a magic constant, and it doesn't. If I try dir, can you dir it? Does this work? Does. Okay. It's probably where we should have started with is dir. Okay. Anyway, though, it does firmware version, chip version. It is doing some stuff. It's not really showing anything. But I think that's because, well, we haven't done anything. So at this point, if we print, so yeah, it is working, but a lot of it's cut off. Go like this for now. Okay. So that is working. Why is this red? Oh. Text. Oh. But actually, when we... I guess that's because it's, it must internally, I guess maybe it sets it to none or it sets the root group or something. Let's try doing this. Print dir qualia. I assume this will have like a .display is my guess, or .graphics.display or something. Let's make a group, main group equals group. Let's make a, let's actually just do that for only right now. DisplayIO. Oh, let me move this so I can see the chat also. Kind of the Wild West for quality displays right now. A lot of them in quick succession, so fast software, that's taking that software to catch up. Maybe wrote a panic reset due to some stuck in a state concern. Forgot about that. Let me see. Import release displays. Why? I have no clue. That's a weird release. Yeah, I think, no, I mean, I think it needs, I think it should need that release display. Honestly, it's weird that this one doesn't have it, but I guess it's internally. I guess it probably happens inside here. Or inside here. Maybe not. I don't know. It's typically necessary when you are using a display that is not built into the firmware. If it's built into the firmware, like board.display, then the core handles it for you. But if you initialize it in Python code, typically you need this because what will happen is when you save your CodePy, it's going to re-execute this again, and then when it tries to initialize this display, typically what happens is it would fail because the SPI bus is in use. You'll try to do it and it will say like warning bus in use or whatever, or I2C if it's an I2C display, but it would tell you like bus in use. And by doing this, you're freeing the bus so that by the time you get to here, it's not in use and it can initialize. Which is typically what you need to do. Graphics.init. Okay, so it is in there somewhere. Using a ruler on BISC bitmaps is nice. Let's see. Okay. Did this run? No, I didn't save yet. Get rid of this one. This one does have .display. So I'm gonna go display equals qualia.display, and then don't could entertain the cat for a minute. I don't want my leg to get bitten, which I don't. Enough. So we then should say display.root group. With the old octopus on a stick here for a minute. Group equals group. This runs. It shouldn't do anything different. Yeah. Let's also get rid of this. Let's make a label. Label. Test label. Wrong one. Display text. Import. Bitmap label. Map label. Label. Create a new label that needs a font, which is terminal font, and then what? Text. Display. Let's just leave that test label. Anchor 0.0.5, 0.5. Anchored position. Display width over 2. Display height 2. We didn't add it to the group. Main group. And this label. So now we should get text in the middle of the display. This works. Nice. Make it bigger. It happens in graphic. Oh yeah, makes a lot of sense. Nice, yeah. Let's get 2, 3. Let's do 3. Display ruler. 20 on the 4-inch guide page. Nice. Do I have a? Okay, no, that was a little speck of dust or something. I was gonna say, do I have a dead pixel? But okay, we have our display up and running. So now what I want to show you is brand new, hot off the GitHub presses in the display shapes library. For those that don't know, display shapes, this is a library a Python library that allows you to draw various different shapes using DisplayIO. And the new feature, hug report to Bablock B. Thank you to Bablock B who added this just very recently. Is arcs, and there's actually a bunch of different arcs that you can draw. So I'm going to grab this sample, and this should look really cool on this display because it's all about circles, basically. I'm going to not grab the whole display, actually, or the whole example. We're going to take only this part of the sample code. This. I will change a few things. For now, let's get rid of our label. Let's call our group, let's just keep main group. We already have main group. We already set it. Let's just use that. Okay. Need to do some imports. Ruler image isn't on the round 21. Might not. It might be that there's no like source for it that's the right size. Get copied too much. Oh, whoa. Yeah, we'd have to, I mean, we could try this one. We could center it maybe and it would still work. We might have to figure out, oh, okay, well, those are probably pixels. We might have to cut it down to 480. If we cut it down, I think it would, I think it could fit on this display as well. Customizable radius, yeah, totally. Yep, you can pick the radius, you can pick the distance, the thickness. There's a handful of different ways you can configure them. The sample one will show us here once I get it loaded up. Okay, arc. So it did install display shapes when I installed Portal Base, I think, or no? No, does not look like it did. Okay, let's copy that over. I'm gonna, well, it should be released now actually, so we should be able to do install Adafruit display shapes. Should actually just give us the one that has this. PyCharm is not going to recognize them because it doesn't know to look in the lib folder, and even if it did, I don't think it knows what MPY format is, so it wouldn't figure it out anyway, but it does look like that's working. Okay, so we've got all of our appends, main group, time sleep, so we should be good here, I think. Let's give that a run. Whoops. Wrong browser. This one. Whoa. I think somebody mentioned that earlier, that it goes a little crazy during the resets. Oh. Is it boot looping? No, I just did it twice. So my computer does, I think, save the code multiple times sometimes. And then by default, if you have auto reload on, which it is on by default, then that means it's going to restart every time a file gets written. So my computer writes to the file and then writes to the file again. The microcontroller resets and then resets again. But anyway, we've got our arcs. So this one draws 3 different examples. This green single pixel line here is one. The yellow one, which I think has a white outline. Oh, actually the colors are way wrong. What is up with the colors? How's it going, Gyron Manful? Sorry if I mispronounced your name there over on YouTube, but welcome. Thanks for tuning in, my friend. Let me try the light. See if that just washes it out too much or what. Kind of give it right there. So we've got a green sort of single line pixel one. We've got a red one actually with a different color outline. I don't know if it's yellow or white. There's an outline on it. And then we've got the blue one down here, which is like a pie wedge. So you could totally make like a pumpkin pie or something if you wanted to by making like 6 of these or 8 of these and then rotating them around. That might be kind of cool. Okay. So again, hug report to Bablock B. This is super cool. The ability to draw these arcs. We had the closest thing like this that we had before was there's a gauge. Is it gauge? I don't know if gauge is the right name, but there's a DisplayIO widget. It might be called gauge or it might be something else. But a different community member made it. It escapes me right now who it was, but it's like a progress bar that goes around a rainbow, so to speak, a semicircle. So it fills up as it goes around. And you could achieve a similar kind of thing with this. The other thing that I think would be kind of cool is you could approximate like an old school radar type action, right? Like if you had this blue pie slice here, if you were like rotating this thing around, and you put a couple other dots in here, you could get kind of a cool, like, you know, submarine radar effect going on. Yeah, exactly. Sonar radar. I think there's a gauge. Yeah, there definitely is a gauge widget. What I don't remember is if gauge is the one that I'm thinking of. It could be, gauge could be the one that's like a needle that points, like a speedometer kind of. Because there is one of those as well, but then there's a different one that's like, I'll call it like a round progress bar. That's not the name of it either, but it's kind of what it is. Okay. So yeah, this is really cool. If you want to get your arc action on, if you want to draw some arcs, the way that you can do that now is inside Adafruit display shapes. There is a example for it. I took the example code here and we got it running on this. Inside of examples, display shapes arc, and it shows the way to draw the different ones. If you'll forgive me, I gotta run to the restroom real fast, sorry. I will be right back in a moment. Okay, we're back. Sorry about that. It was not quite an emergency just yet, but I was not going to make it the rest of the stream and was only going to get more antsy and distracted, so be good. We got about an hour or so, maybe a little longer. We'll see how it's going towards the end, but we got a little bit of time left, and I wanted to not be squirming too much. Okay, so display shapes arc, check it out. One of the things I want to try to do with it is actually, I want the Python version. Let's delete that. Blammo, delete it. Oh, I should use Circup uninstall. Circup has an uninstall that I never use. Excuse me. There's Jay Posada. Jay Posada, Jose David. He made. I don't believe he made the one I'm thinking of. But again, I don't recall for certain, so I could be wrong. Jose has made a handful of widgets, though. Several of the ones out there are ones that he's made. The what I'll call again the round progress bar. This one sticks out in my mind because around that time I implemented the boundary fill inside of the core, which is like a paint bucket fill. And so that curved progress bar, whatever it is called, the functionality of it sticks in my head for that reason, because I was diving really deep at that time into the core to try and implement. That was honestly like the first like really sort of even remotely major thing inside the core that I worked on. Let me show the API real quick for the ones that are in the example, and then I'll tell you what I want to try to tweak on this to play with it a little bit further. So in this example, it draws a circle. The circle is not new. That was already existing. That's just the dot in the middle right there. There's our first new thing, which is an arc. It gets XY, radius, angle, direction, segments, arc width, and outline. And this is the red one with the white outline right there. So let's play with this a bit. Right now it's on angle 90. Let's make that angle 45. Just get a look at what that does. So that is like your angle, like your overall, kind of width or length of your arc there in degrees. So 45 means we get a 45-degree sort of slice of pie there. If we wanted, a full semicircle, we could give it 180. That would match the green, I think. Yeah, so now we've got kind of the same thing going as the green. You could make a pretty sweet rainbow with this. That'd be pretty cool. Could be Seagrover. Yeah, I don't remember for sure. I'll have to look it up. It'd be another good thing to draw in this display too. Angle, let's drop that back to 90. And then, okay, so direction. Let's change this one next. I'm gonna save this. Let's let it run on 90. So that's back to the original now. Our red and white one there. So direction here, this is which way it's pointed. So right now we're on 90. If we go, let's do 0, then I think it points to the right. So I played with this a little bit the other day. So I know some of this, yeah. Points to the right. So we can, 90 was our length, our total width. And then this is now our direction. Which way are we pointing? And it starts to the right, and then it works its way counterclockwise. So 90 will get you to the top. Segments. I don't really segments I think is like how many polygons is it going to use to make? Yeah, I think it's how many polygons. So like if you look at this one, it's a little bit blockier now. It's not quite a smooth curve. It kind of has these straight segments. This would be like a triangle, I think, maybe. Yeah, well, not a triangle, but like a greater than sign almost, pointing up, an arrow. This would be an interesting way to make arrows. It's not really meant for that, but yeah. So when we have segments too, it's how many polygons are we making our curve out of? So the more segments, the more polygons you make your curve out of, the smoother your curve is going to be. If you wanted to have rigid corners and straight lines, then you would use very few segments. And if you wanted to have nice smooth curves and no rigid corners and no straight lines, then you would use a higher count of segments. The more segments, though, I presume, like, the more processing power and stuff it takes as well, so. What else do we have? We have arc width. I think that's like the thickness. So on our red one here, it's like how tall it is in this up and down, I think. Yeah, so we can make it thicker like that with the thickness. And then we have outline and fill, which is the same as all the shapes, all the Adafruit display shapes. The green one is XY, radius, angle, direction, segments, arc width. So they just set the arc width to 1 in order to get that single pixel. Set the outline only. And then the blue one, which is the pie, this is the one that's actually the most different. What does it do? Why does it draw the pie? Because of this, maybe. Yeah, I think it's because of this. So it has XY radius, all that's the same. Angle, direction, it went backwards by 90, so we were turning counterclockwise. This one is now going to turn clockwise to end up pointing down, just like it does. 10 segments, and then what it's done here is it's basically made the arc width the entire radius of the circle that this would represent. That's pretty much what it's done. Because this value it's using right here is the same -5 though. Min. And the 5 is actually probably just the size of this one in there? I don't know. Yeah. I think the 5 is because of this one in there. What does it do if we take this out? Can't tell the difference. Put it back for now. Okay, so by giving it a super huge arc width, by giving it an arc width that's basically the same as the radius, you make it so it's going to draw a pie. It's going to draw these two straight edges here, because these two straight edges are basically the same as these two edges here. Conceptually, right? They're just the straight parts of the little macaroni pipe there. It's just this one is much wider, so they kind of meet in a corner there. If we would take this circle off, we could probably see a tiny little cutout circle there. Ooh, what's that? Let me catch up on the chat here too. Would angle 360 with X segments create an X-sided polygon? Yeah, I don't know. Let's try it though. Let me also see this. Seagrover showed this as a pretty sweet looking gauge going there. So that's got a display. Wow, that's a nice looking gauge. I don't know. I think that is different from the one I've seen before, or it's got a lot of extra stuff putting on it at least. Nice. Yeah, that's really cool looking. Is that a, looks like probably a rack? A rack widget there? Euro rack? Nice. Okay, so let's try this. Let's go angle. Let's go 360. This is the green one, so 360. This would make it a full circle. My instinct is yes. Yeah, my instinct is yeah. You can make regular polygons, I think, by doing angle 360. I don't know if regular polygons is the right term. I think that is a term, but I don't know if I used it correctly. So if you wanted a, let's say, pentagon, you would set this to 5. Yeah, so now the green one is a pentagon. Maybe make this a little bigger. If you're familiar with OpenSCAD, which I happened to use earlier today, so I'm not only familiar with it, but it's also just on my mind today. If you're familiar with OpenSCAD, this is basically the concept of fineness in OpenSCAD. They use $FN for the variable that represents this concept. So if you wanted a hexagon, then you could do 6. You know, you could do an n-gon, right? Whatever number you set there, you're going to get a regular polygon with that many sides. And if you set it big enough, then your regular polygon with that many sides is going to look like a circle to the human eye. Your Rec VCO module looks like an infernal device. Cool, thanks. Yeah, for sure. It looks amazing. Yeah, I definitely agree with that. Yeah, so extra credit there on the arcs. You can use it to make the regular polygons. There is polygon here as well, but this one actually just takes points, I think. Yeah, it just takes points. So if you could make the same shape with this, but you'd have to get these points either manually or through some equation or something, which like there is an equation that would get them for you. In fact, it's inside this arc somewhere, but okay. I would like to be able to rotate it, right? As soon as I saw this blue one here, the first thing my mind thought of was like a sonar graphic thing where this is spinning around. Maybe it's a little bit narrower, like arc here. Maybe it's like only like 30, maybe. Something like that, and then it's like rotating around. And then like occasionally it puts a little dot because it finds, you know, another ship or whatever, right? Or a fish if it's a fish thing. But can you rotate it? Yes, that is the not quite $1 million question, but that is the question of the day, let's say. The short answer is no. The short answer is no, you can't. The long answer is it's Python code, and we know Python code. We could do a lot with Python code, so we can make some things happen, I think. The short answer is, though, inside of Arc, it extends group. It only has init. There's no properties. There's no setters. There's no nothing. There's just init. When you call init, it does these things. It calls super init to create the group. It sets direction to something, shift by that. It creates a list for points. It loops over the number of segments plus 1. It does some trig in order to add the first set of points to the list. Those are the outer points. Then it, as long as it has at least 2 width, then it loops again. It does some more trig. It generates a second set of points for the inner points. I think I added this print, maybe? We should probably take that back out, actually. If that's in the official library, we should probably take it back out. I don't know if I added it or not. I mean, I don't think that I committed. I remember doing something like that, but I don't think I committed. Oh, this is blue, though. So, yeah, I have changed it, I guess. But what did I change? Is that what I changed? It is. Okay, I added this. Okay, yeah, so that's not in the official one. So it does. I added that for now. And then it says if you have VectorIO. So that's another interesting thing about this is it has this conditional import for VectorIO. So we try to import VectorIO. If it succeeds, we set that to true. If it fails, we set that to false. If it did succeed, we use VectorIO polygon. If it failed, then we use display shapes polygon instead. So right now, there is not really a way to change it. What we would need to do to change it, if we hypothetically would want to change it, we would need to recalculate all of this. We would need to recalculate this based on the current value for direction. We would need to recalculate all of these points based on the current values for angle, segments, direction, radius, arc width, all this stuff. And then once we had a new list of points, we would need to either create a new polygon or change the polygon. I'm pretty sure you can on a VectorIO, specifically on a VectorIO polygon. I think you can change the points, maybe. I think you can. So I think I tried to use it for rotation once. Yeah. So it says points is one of the parameters, one of the arguments, but it also has points as a property. I think you can change the points. Okay, so we're gonna start hacking up on this arc. So I want to be able to update it. I want to be able to rotate it specifically. Arcs will simplify this. Yeah, I forgot about that. About your one of those electric eye widget. I forgot the name of that. It's like an old analog sensor. Had a few overlapping shapes to get that one to work. Just trying to update mine to Alpha 5. Holding down boot button turns part of the screen yellow. Yeah, the screen, whenever mine's resetting, the screen's definitely getting a little crazy on it for sure. It's okay. So what we want, I think we're going to refactor this to have def underscore generate points. And I'm going to put all of this inside of there. Except for this, actually. It's going to be just points. Self.points, actually. Self.points? Yeah, self.points. And self.direction. direction. Oh, this is weird. It's gonna like change your direction on you. Okay, I'm gonna actually make these underscores like this. We're gonna call this shifted direction, I guess. Self.direction equals direction. And I think we want to keep all of the things. So self.angle, self.segments, segments. How's it going? My friend over on YouTube, my apologies, I don't know how to pronounce your name. Self.segments, angle, direction. We did direction already, math.py. So what's alpha? Oh, gets created. Angle, segments, direction. We need thickness, radius, and arc width. That's what the thickness is called. Radius, self.dot width. And it is score. What we're going to do is we're going to make properties for these, and then we're going to make it call generate points. We're going to make it like refresh itself whenever you set them. Partially, though, we do want to split generate points from create the polygon, basically. Generate points is in here. Whoops. Okay, this will now generate points. It will put all the points into points. One thing we should do is empty that out first. So get rid of all the old points and then generate all the new points. And then the next thing we want to do, or the next thing we want to refactor out, def init polygons, which is this code right here. We want to go self.empty, self.clear, self. We want to remove all the old one. Well, init polygon? Init polygon. It's only one polygon. Init polygon. Actually, do we want to remove? I don't think we need to remove the old one because we only want to init once, and then after that we want to not init again. Although it will be awkward a little bit because display shapes polygon, I don't think you can update the points on, but VectorIO, I think you can. So for the display shapes one, you actually would need to call this and create a new polygon. But I'm mostly interested in VectorIO because this device has that, and all of the newer devices moving forward, I suspect, will have that. Do not have this copied anymore. Oh, I didn't do fill, actually. We can do actually just self.fill. That one doesn't need the underscore. Okay, so we have generate points, we have init polygon. So in our constructor, inside of init, we want to go self.generate points. And after that, we want to go self.init polygon. And if we did everything right, then this is now back to working. So let's check if we did. Alias. Nope, we have no alias. Which seems reasonable, obviously, since that should be radius. Some red wire on top. Okay, so that's back to working. The angle is different. It's just me, or is the angle? The angle is different. This was pointing down before. I think our shift might have gotten us here. Right. Because this had set it to direction. Shifted direction. This should be shifted direction. It gets used down here. There we go. Okay, very good. Now we should be able to call generate points, which will recreate our list of points, and then we should be able to set that list of points back onto our polygon. So create that. I'm going to put it on self just for convenience. We don't really have to. We could get it from other ways, but I'm just going to put it there. So now what I want to do is, so I'm most directly, I am interested in rotation. So the first thing I'm going to do is the angle. So I'm going to make a property def angle. That is going to return self dot underscore the private angle, and then we're going to have a setter, angle dot setter. Value new angle. Let's call it new angle. This will go self dot angle equals new angle, and then we go self dot generate points, and then we go self dot. So for one thing, we need to say if not self dot if not has adder self vector there's using, let's just use this actually. If not have vector IO raise runtime error. And let's see. Yeah, can only change points with vector IO, not polygon. I'm gonna do it this way for now. So if you're not using vector IO, this gives you an error. Not allowed to do it. You are using vector IO, then it does not give you an error, which means it goes on, sets angle to there, generate points, and then we can go self dot polygon dot points equals self dot points. I don't know why all of these lines have space in them. Okay, so theoretically we should be able to set angle and it should update itself. It is sleeping here. So that's like 10 times a second. We could speed it up eventually as well. Let's see though. So this is the blue one, arc 3 angle. Let's go angle plus equals 1. Maybe plus equals 5. I have no idea how well this will work, if at all. Nope, not at all. VectorIO polygon, probably none. Let's get to here. Arc has no VectorIO polygon. Didn't I put it on self? Put that on self? Init polygon. But no, I mean, that's definitely the same self. Did I mistype it? That's perplexing. Is it because we didn't create it in here? Do you have to like explicitly create it inside of init? And then also set it inside of a function? As we called generate, we called init. Init is where it should self.vector.io. I mean, does this not have vector.io? I'm making the assumption that it does. That's wrong. It does, okay. Okay, well, let's try it like that, I guess. It still fail? Oh no, we're on this now. Okay, after all that, it looks like I might have been wrong. It does just say attribute error cannot set attribute points. I really thought you could change the points though on the vector.io polygon. Cannot set attribute points. Yeah, looks like maybe I was just solely wrong. I interpret this as a property. Is this not a property? All right, we're gonna go to the source here and take a quick look. So shared, I'm gonna go to shared bindings. IO. It's gonna be C. Okay, so get points is here, and it calls common how vector.io polygon get points. set points calls CommonHow VectorIO set points. I mean, from here it looks like it exists, but I guess if we get inside there and it's just like raise an exception. So that CommonHow, that should be over here, I think, inside shared module. Set points. VectorIO polygon debug, set points, clobber points list, on dirty. So it calls clobber points list and it passes in a new points list, which sounds like it should overwrite the points list, which is exactly what I would want it to do. So am I missing something? Can't set attribute points. Print type self.vectorIO polygon. Print dir self.vectorIO polygon. So that from this code, it really looks like this should work. I don't see where this is getting raised from either, so I don't know. A little extra confused here. Okay, well, there you go. That's none. There's your problem. So VectorIO polygon is none. None. Does this not work? Put VectorIO polygon on self. I know what the problem is. This says if arc width greater than 1, ours is not on the blue one, so we're not using VectorIO. Is that true? Arc width? No, well, no, because our width is gigantic, actually. Because we talked about that earlier. Our width is the whole pie size. Step back. Put self. Does this print before our type? Okay, so I don't know. I seem to be having a failing of object-oriented Python code, I guess, because in my mind, self here second here. So that should be the same self that's here, the same self that has all these things, the same self that we then are here. I'm super confused. Maybe we're calling angle before we do init? That doesn't make any sense. Length is 1. Definitely have the polygon. And I mean, we could even say print type self 0. This will be our polygon. But why can I not have it on self.vector_polygon? So that part worked. Why can I not have it on that? That's weird to me. I don't understand that. I feel like if we put this here, when we are inside of here, it should still have its value, right? Why would it not? I mean, unless if something else was setting it to none, like that's possible. Something else could set it to none and then it would be none, but that's not happening. Do I... No, self gets passed automatically. I don't know. I do not get it. That breaks the rules of storing stuff on self that I am familiar with. This is like totally legit. Totally legit in the rules that I'm familiar with, but somehow that's actually null. So I guess we'll use self 0 and we'll just assume that nothing else has appended anything to self. Yeah, I don't get that. Firmware 100. So I did that in order to try to see if it would make a difference, and it didn't. Put my prints back. But that one we did not have originally, and I put it there, like, my thought on that one was, like, maybe because we don't set VectorIO polygon inside of init, maybe that means that the one that is inside of here is, like, local or whatever, right? Like a different instance that's not the same one as the one here, and so that's why I went back and set this to none here. But it didn't make a difference. We still get the same. We do still get the same outcome. Thank you for mentioning it though, because I should go back and delete it. Now I have it commented out, but we'll delete it eventually. So it does still. Yeah. So now we get 144 has no VectorIO polygon because it tries to say dot this. But yeah, I don't get why. That's very weird to me. Are we using both? So my understanding was we were using VectorIO only. But actually now I wonder if we're using both. Okay. So VectorIO is... Oh, you know what? We're not... what I said earlier... No, because this is too big. It's definitely not one. Let's turn these off. Okay, our blue one is not a VectorIO polygon anyway. Because I turned off display shapes polygon and now it's gone. So if I put this back, then our blue one's going to come back. And that tells us that it's not a VectorIO at all. Which means we can't change points, and that makes sense. But it does... It's creating one of each, I guess. But what is it using the vector IO for? Okay, I thought this was either or, but it's not. It's if this is true, then do a vector IO thing, and if this is true, then do a display shapes thing. If outline is not none. Okay, let's do fill. Let's do fill blue. And outline none. Okay, so now we're not using that one at all. Which that's gonna throw us off. We want the. I thought that one was using vector IO too, but vector IOs are always filled. I should have remembered that actually. Vector IOs are always filled. They can't do outline only. You could make 2 of them. It'd be really hard to shrink it though. How are you setting up the display? Yeah, pretty much that. Well, I don't have a URL. This complains display not. I don't know. Maybe put your full code. Mine is basically what you have. I have a different display, but it's basically what you have. The only other difference is I don't have URL. I took out URL, and I'm using round 21, not round 40. And then it's on, after you do that, it's qualia.display. Hey, Tim. Hey, I'll join late. Looking forward to rewatching. Nice. Yeah. How's it going? First of all, thanks for tuning in. So nice. It's nice to see you, my friend. Hope you're having a nice day. All right, let's try this now. So I think maybe we can get our rotation action on this one. Yeah, there we go. Okay, so now our next problem though is that get off the window. Now our next problem is that it's like wrapping around. Pretty sweet looking though, I'm not gonna lie. Why is it wrapping around? Oh. Wait. Okay, let's say print line of points. I want to make sure that that's clearing out and then getting recreated, and it should have the same number of points, I think. They should just be different points. But in reality, it looks like it's going to have more points, but I don't know why we're getting more. That works. Got an arc example going. Nice. Yeah, cool. I would have never figured out display equals quality display. Yeah, I like to do that. Display equals, for built-in ones, it's like display equals board display, but I always like to set a variable called lowercase display. That way I can use it the same in all my code. So it's always having 22 points. It's not continually adding like I thought it was. What's weird is it's like the number of segments are getting smaller as it goes around. I don't know. Oh, that's, I guess because it's never... Oh, I think... Wait. I'm doing the wrong thing, aren't I? I want to be, this whole time, yeah, I want to be doing direction, not angle. That's my problem. Well, okay. I guess let's leave all this here. Really, yeah, this whole time I was meant to be doing direction, not angle, but I got a little confused there. Def direction, turn self direction. Shifted? Should we do shifted? No, I think we should give them back whatever they gave us. We'll recalculate shifted to be whatever we want when a new one comes in. Not a fan of requiring portal base. I mean, it doesn't require it per se, right? You can initialize the driver without it. I like the one line import and initialize of the screen, so I'm willing to do whatever I need for that. If that's import portal base, then I don't really have a problem with it. Especially since you're allowed to use, like, take and use whatever you want, right? Like, I have technically imported and used portal base, but we're just getting the display and treating it like a normal display and doing nothing else with portal base. So, like, I don't know, it doesn't really change anything, I guess. It doesn't really change the way anything happens after we get the display. So I just choose not to use that portion of it. Just go straight to DisplayIO. Let's go and do back down to here. Direction setter, direction, new direction, self dot underscore equals new, and then we need to recalculate the shifted direction, which is gonna come from self dot angle. I guess we should recalculate this if the angle changes too. Yeah, we probably should recalculate this. We need to do this actually before we call generate points here. Since angle changed, or could have changed, we want to recalculate. And then here we can go same thing. So to set direction, calculate the shifted direction, then call generate points, then call, please do not bite my leg, buddy. Generate points, and then we do this basically to update. And then I actually do want direction, not angle here. This is actually the effect I was going for. If it works, how I'm imagining, we'll see. Yeah, nice. Yeah, that's sweet. So if you could do something like that and then maybe put some little dots in there occasionally whenever it, you know, senses another submarine or whatever. So yeah, it comes with a lot of caveats. The updating of the direction, I'll use the proper term, the updating of the direction is possible, but comes with the caveat of it's vector IO only, which means effectively you can really pretty much only do it on ones that don't have an outline. Like if this had an outline, it would get totally messed up, I think. Sonar, sweet, nice, thank you. Yeah, I like the way this came out too. Is there not a yellow? Oh, there's white, okay, do white. Oops. Let's see, default for the default example, which is the Wi-Fi symbol tester requires portal base. Didn't figure out, might not be much required. Yeah, I don't know. I go back and forth on it. It just depends on what you want to do with it, right? It's going to be better for different people different ways. Some people want to just fetch right away from an API that's got it JSON and they know exactly what they want to fetch or whatever. So it's like super duper easy if they use that. So because we can only update vector.io, it means that if we have an outline, it's going to be messed up like this, right? The outline is stuck, right? It's not updating. We could achieve the visual effect of the outline updating by, like, we could recall init polygon. Instead of setting the points, we could, like, delete the old vector.io and the old display shapes polygon. So, like, instead of this, we could say self.pop. There should be two things when the outline is true, which I'm just going to assume it is here. Obviously, the code would be a little bit different if it wasn't. We need some ifs, or I don't know if that fails if there's nothing in there. Maybe, I don't know if it does. So we'll remove them both, and then if we called init polygon again, now it will work with the outline, but it will be slower too, I think. Yeah, it's way slower. And it gets that blinky effect because I'm not actually sure why. Maybe it display.auto refresh equals false. Let's try this. Maybe this might get rid of the blinkiness. We don't have display in here. Oh, right. Yeah, that's very difficult, actually. Okay, yeah, let's just move that out. Here. I mean, we could just turn it off, I suppose. Then just call refresh after the direction. I think this might get rid of the blinkiness of the outline, but it is still going to be slow. Yeah, it got rid of the blinkiness. It's got some weirdness on the edges. Like, some of that is the camera, but some of that totally is the display as well. Some of that weirdness on the edge, I can see some of that with the naked eye. I think that's just like how fast it's updating the display versus how fast it's moving. Because it's doing the display shapes now, like, that part's way slower. When we had only the vector.io, so only the fill with no outline, that can actually go way faster because updating the points is way quicker than recreating both the vector.io polygon and the, what I'll call bitmap polygon, but display shapes polygon. We could try to, like, let it go faster, but I think it's like going to be limited to, yeah. Also, running faster like this seems to have exacerbated our staticky edges. Let's swing the other way. What if we said quarter second, or no, 1/5 of a second, and then what if we said, let's try 10 degrees instead of... Something like that's not a bad effect. I mean, we are getting back to having a whole lot of weirdness on those edges, though. I think that's just kind of the refresh, though. That's a bit, that might just be the nature of the beast on the refreshes on these displays. I don't know. But with Vector.io, it looked pretty good. I think if we went back to the Vector.io one without the outline, it looks pretty solid, I think. Well, yeah, obviously it looks solid, but can't change the circle fill background color to anything other than black. It's just the center of the dot, never mind. Okay, yeah, I'm not sure what you mean. Perfect for this time of flight sensor on a mini tank. Turns and scans the direction move in after encountering. Oh yeah, that'd be super cool. If you had like if you had a time of flight and if you're rotating around and so you're like seeing the obstacles, if you can keep track of your 360, then yeah, you could totally plot points in here and show like which direction it's looking at the current time. That'd be a sweet output, I think, for sure. On the 4-inch round, I get a noticeable flicker. The bigger the display is, yeah, for sure. The bigger, exactly right. The more, really what it boils down to, the more pixels you're changing, the longer it takes to do and the more of this kind of weirdness you're likely to encounter. Yeah, that's kind of the effect I'm after for sure. We won't be able to do the fading the way it does on those. Like it kind of has that trailing edge that fades away. We're not quite to the point of being able to do anything quite like that. But yeah, if we change this up to a green and if we added a couple other concentric circles in here, and maybe if we slice it up, I don't know for sure if I like the lines. Might skip the lines. I'd have to see it both ways, maybe. Okay. Well, it's something to think about. I don't know. I don't know if it is, well, I guess really what it comes down to is I don't know how I would want to approach actually adding it for real. So what I've hacked together here works. I would say it works better with the Vector.io only arcs than it does obviously the joint display shape and Vector.io arcs. It does work, but obviously better on just the ones that are vector. I think it might be worth trying to improve the code a bit though. Like, I don't think it's ready to kind of like PR this back right now. I think what I would want to do is use this methodology if we can. So like inside of here, we want to do a check and say, are we a Vector.io only one? You know, i.e., are we a fill only, no outline? If we are, we want to do this. If we are not, then we would want to do this. Maybe we could pop only the display shapes. We could actually still change the points and then only add the display shape one. That might get us a little bit of time back. I don't know how much time it takes to actually create the Vector.io. It should be better on memory, though. We shouldn't be garbage collecting the Vector.io if we were to update it instead of create it. Add in some... Okay, palette fader actually maybe could do the trailing thing. I don't know about around the circle. Probably with some trig. I don't actually know trig, though. My level of understanding with trig is like... just try sprinkling in sine and cosine and adding 90 or 180. Hoping for the best. Guess and check, see what it does. That's kind of like my level of trig understanding. There is probably a way to do it, though. Yeah. So you could do it with a bitmap. You could do it with a bitmap. I don't know if that we have an easy way to rotate. We have bitmap tools.rotozoom, actually. That's probably the way to rotate bitmaps. That is the way to rotate bitmaps, I should say. Easy, the only way I know of currently. All right. I think I'm going to take off for now. This is some good food for thought. I think in order to be ready to submit, I would want to take a little care here to have logic to like only do the points when we need to only do the points and not do this when we don't need to. That would speed it back up for the cases that can be fast, at least. Yeah, that's the main thing, I think. I think it'd be pretty much ready to submit after that. We need to, like, there's a bunch of prints I added we could get rid of, but functionality-wise, I think if we had that logic in there to take care not to recreate them when we don't need to, then that's, at least to my thought, the main thing it needs to do before I'd consider it ready. If you keep an eye on if you're interested in this and you keep an eye on the display shapes repo, then you'll probably see me submit a PR in the next couple of days, and I would appreciate a review if anyone is interested. Or if not, then you can just check it out there, and eventually it will get merged in, and you'll be able to use it. I will say thank you to everybody for watching. Let me catch up on some of the chats here, and then we'll finish up with the goodbyes. Thanks, Tim. Yep, for sure. You're welcome. There you go. There's some trig. X equals, yeah, radius, center. I don't know. Simple phosphor brightness fading is pretty doable if you're not trying to achieve transparency. Phosphor displays don't have the transparency in the real life. Keith has a learning site. Was going to try to make a foamy guy icon real quick, but can't seem to even change the background color. Thought that counts. Nice. Yeah. I don't think I've ever put my little Cyclops guy on a CircuitPython board, actually. I can't recall. I don't think I have. All right. Take it easy, everybody. I hope you all have a good rest of your evening. Hope you all have a good weekend and all that. If you are ready for some more CircuitPython action tomorrow, I'll be back tomorrow morning at 10 a.m., which is the normal time that I stream over on my own channel, Saturday mornings at 10 a.m. So I'll be back then. I don't know exactly what we'll be working on yet, if it'll be this or something else. I haven't quite decided, but if you're interested in some more CircuitPython action, then I would encourage you to come back then. Otherwise, I will bid you farewell. Thanks again for hanging out. Thanks for watching along. Thanks for all the questions and comments and everything in the chat. So long and good night, everybody. Yeah, and thanks again for watching is all. So I'll see you later next time.